Close your eyes for just one moment. Imagine a child, barefoot, sitting beneath a vast Indian sky so packed with stars, it looks like God spilled diamonds across the darkness. This child has no telescope, he has no calculator, he has no university degree, no research grant, no laboratory. He has only his mind, and from that single, burning, restless mind, he will shatter the silence of 1,000 years and change the way every civilization on Earth understands the universe. Yes, this is not a fairy tale. This is not a myth. This is the true and breathtaking story of Aryabhata, mathematician, astronomer, philosopher, and perhaps the most underestimated genius in the entire history of human thought. Stay with me until the very end of this video, because I am going to reveal something so striking, so jaw-dropping about Aryabhata's legacy that most people alive today have never heard it. It will shake you, it will move you, and it will make you see the world differently. So do not go anywhere. Welcome back to Numbers and Narratives by Blesswright, the channel where we do not just tell you history, we make you feel it in your bones. I am so glad you are here today because the story we are about to explore together is one that deserves to be screamed from rooftops, taught in every school on every continent, and celebrated with the same awe we give to the greatest names in science. If this is your first time on this channel, welcome home. Please hit that subscribe button right now. Tap the notification bell so you never miss a story like this. And if you feel this video moves you, and I promise it will, share it with someone who still believes that genius only comes from certain places, certain people, certain centuries. Because today we are going to prove them wrong. This is the story of Aryabhata, and it begins not with a bang, but with a breath, the quiet, holy breath of ancient India, a teeming with questions no one had yet dared to answer. The year is 476 CE. The Roman Empire is crumbling. The great classical world is fracturing under the weight of invasion, plague, and the slow grinding darkness of what Europe would come to call the Dark Ages. Across the known world, knowledge is dying. Libraries are being burned. Scholars are fleeing. Centuries of accumulated wisdom are being lost, erased, forgotten. And yet, in the fertile golden-lit plains of ancient India, something extraordinary is happening. Something that will defy the fall of empires and outlast the ruin of civilizations. In a land humming with the ancient texts of the Vedas, in a culture that had been counting and calculating for centuries before the Greeks ever picked up a stylus, a boy is born. We do not know his exact birthplace with absolute certainty, though many scholars point to the region of Kusumapura, which we know today as the ancient city of Pataliputra, close to modern-day Patna in the Indian state of Bihar. Some traditions also connect him to the region of Asmaka. But whatever the precise longitude and latitude of his birth, what matters is this. Something in the cosmos stirred the day Aryabhata drew his first breath. Something ancient and vast leaned in close to watch what this child would do. He grew up in a world of ancient wonder. The India of his childhood was not primitive. Do not make that mistake. This was the land of the Gupta Empire, one of the greatest intellectual and cultural flowering periods in human history. The Gupta era was to India what the Renaissance would one day be to Europe. Art, music, literature, philosophy, and mathematics were not luxuries. They were the very heartbeat of civilization. And at the center of this heartbeat was a love of numbers that ran deeper than any river. We can only imagine what Aryabhata's childhood was like. History has not given us diaries. Ina has not preserved letters from his mother, has not recorded the exact moment he first looked up at the sky and felt that electric, terrifying hunger to understand. But we know enough. We know that when he was still a very young man, most historians believe he was around 23 years old, he produced a work so staggering in its scope and brilliance that scholars are still mining it for insights 15 centuries later. That work was called the Aryabhatiya. Say it with me. Aryabhatiya. Let that name settle in your chest for a moment, because this was not just a book. This was a declaration. This was one human mind, one solitary, burning, tireless human mind, standing up before the vastness of the unknown universe and saying, I see you, I have been watching you, and I am going to understand you. The Aryabhatiya was written in Sanskrit verse, not prose verse. Imagine being so in love with the beauty of numbers that you choose to write mathematics the way a poet writes about the moon. Aryabhata was not just calculating, he was singing. He was composing a symphony out of digits and cosmic distances and the slow, majestic turning of the heavens. Every line was compressed, dense, layered with meaning. Every stanza held within it a world of thought that took later mathematicians years to fully unpack. Let me tell you about one of his greatest triumphs, and I need you to feel the weight of what I'm about to say. For thousands of years, mathematicians had wrestled with one of the most fundamental questions in all of geometry. What is the precise relationship between the circumference of a circle and its diameter? They knew there was a ratio. They called it, eventually, pi. But how close could they get to the true value? Archimedes, the great Greek genius who had lived roughly 7 centuries before Aryabhata, had estimated pi to be somewhere between 3.1408 and 3.1428. This was brilliant for his time. Genuinely, staggeringly brilliant. But Aryabhata went further. In the Aryabhatiya, in a passage of breathtaking elegance, he wrote, and I am paraphrasing from the Sanskrit, that 100 plus 4 multiplied by 8 plus 62,000 gives the approximate circumference of a circle whose diameter is 20,000. Work that out, and you arrive at a value of pi that is approximately 3.1416. 3.1416. Honor that is accurate to 4 decimal places. And here is what makes it even more remarkable. Aryabhata himself used the word approximate. He called it asana, meaning near or approximate, which means he understood that pi is irrational. He understood 15 centuries ago, without computers, without modern notation, without any of the tools we take for granted, that you cannot express pi as a perfect fraction. You can only approach it. You can only reach toward it. The way you reach toward the horizon, forever getting closer, never quite arriving. Think about that. Think about what it means for a human being in 499 CE to understand that some truths are infinite. Some numbers never settle. Some answers keep unfolding forever. That is not just mathematics. That is philosophy. That is theology. That is one of the deepest things a mind can grasp about the nature of reality. I want you to sit with that for a moment before we move on. Now I want to talk about something that, when I first truly understood it, made me put down everything I was doing and just sit in stunned silence. Because what I am about to tell you is the kind of thing that rewrites history. Or rather, it reveals the history that was already there, the history we forgot, the history we ignored. In 499 CE, 1,000 years before Copernicus published his heliocentric theory and rocked the Western world to its foundations, Aryabhata proposed that the Earth rotates on its axis. Read that again. Let it sink in. 1,000 years before Copernicus. 1,000 years before Galileo was placed under house arrest for daring to agree. 1,000 years before Bruno was burned at the stake for a similar belief. In 499 CE, in the golden plains of ancient India, a 23-year-old mathematician looked up at the night sky, watched the stars wheel overhead, and instead of saying the stars are moving around us, he said, "No, we are moving. The Earth spins. The stars only appear to move because we are rotating beneath them." In the Aryabhatiya, he described this with a beautiful analogy. He said it is like sitting on a boat moving forward. The trees on the shore appear to be moving backward. The observer perceives motion in what is still, and stillness in what is moving. The stars are not revolving around the Earth. The Earth is spinning, and we are the ones moving through the sky. Can you feel the magnitude of that insight? Can you feel how far ahead of his time this man was? In a world where most people believed the Earth was flat, or that the heavens were fixed wheels turning around us, or that the cosmos was a great clockwork machine with humanity at its center, Aryabhata was already pointing at the truth, in already seeing what nearly everyone else would miss for a millennium. And what happened? In some quarters he was opposed. Some later Indian astronomers pushed back against his idea of a rotating Earth. The full implications were not always embraced. This is the tragedy that runs through so many great lives in science. The world is rarely ready for the person who sees furthest. The light arrives before the eyes have learned to bear it. But let us not linger in tragedy, because Aryabhata's story is not a tragedy. It is a triumph, a long, slow, magnificent triumph that spans 15 centuries and still has not reached its full conclusion. Let me tell you about his work in trigonometry, because it is here that we see him not just as a brilliant individual, but as the founder of an entire language. A language that engineers, architects, navigators, astronomers, physicists, and computer scientists still speak today. Aryabhata developed what we now call the sine function. The word sine itself carries his fingerprints. In Sanskrit, the term was jaya or jiva, meaning cord. When Arab scholars translated his work into Arabic, they rendered this as jiba, which was a meaningless combination of letters in Arabic and was therefore written in abbreviated form. When later European scholars translated from Arabic to Latin, they misread the abbreviated jiba as jaib, an Arabic word meaning pocket or fold, and jaib was translated into Latin as sinus, meaning curve or fold. From sinus we get sine. Every time a student today types sin into a calculator, every time an engineer uses a sine wave to model electrical current, every time a musician talks about the sinusoidal shape of a sound wave, they are, without knowing it, unechoing the Sanskrit word that Aryabhata wrote down 15 centuries ago in a land of mango groves and monsoon rains and brilliant burning mines. His sine tables, detailed tables listing the values of the sine function at intervals of 3.75 degrees, were the most accurate in the ancient world. They became foundational tools for astronomy, geography, and navigation. They were studied, copied, adapted, and built upon by mathematicians in India, then by Islamic scholars during the Golden Age of Islam, and then by European mathematicians during the Renaissance. Line by line, calculation by calculation, the knowledge flowed westward across the centuries, like water finding its path through rock. Aryabhata's contributions to algebra are equally profound. He developed methods for solving linear equations that remain recognizable to students of mathematics today. He worked on problems of indeterminate equations with multiple possible solutions, using a technique he called the kutika, meaning pulverizer. This method of solving what we now call Diophantine equations was so powerful and so elegant that it laid groundwork for methods developed in Europe more than 1,000 years later. He also developed formulas for the sum of arithmetic series, for the sum of squares and cubes of natural numbers, and for calculating square roots and cube roots with remarkable precision. He understood the concept of place value in the decimal system, the revolutionary idea that the position of a digit determines its value. And he worked within a number system that was already centuries ahead of the Roman numerals still being used in Europe, the decimal place value system. Think about what that means. Think about the world without it. Without the concept of zero and place value, you cannot do long multiplication, you cannot do long division, you cannot build logarithm tables, you cannot calculate compound interest, you cannot design a bridge, a computer, a satellite, a medicine dosage, a rocket trajectory. The decimal place value system, developed and perfected in ancient India, embedded in the mathematical tradition that Aryabhata inherited and extended, is the foundation upon which all of modern science and technology is built. And yet we rarely stop to say thank you. We rarely stop to look back through the corridors of time and acknowledge where this gift came from. But Aryabhata was not only a mathematician, he was an astronomer of the very first rank, and some of his astronomical calculations still astonish scientists today. He calculated the length of the solar year, the time it takes the Earth to complete one orbit of the Sun, as 365 days, 6 hours, 12 minutes, and 30 seconds. The true value, determined by modern instruments, is 365 days, 6 hours, 9 minutes, and 10 seconds. Aryabhata's error was approximately 3 minutes and 20 seconds. 3 minutes and 20 seconds. With no telescope, with no satellite, with no atomic clock, with no computer, with nothing but his mind, his eyes, and the accumulated observations of Indian astronomy stretching back through the centuries. He came within 3 minutes and 20 seconds of the correct answer. And he also calculated the sidereal rotation period of the Earth, the time it takes the Earth to rotate once relative to the fixed stars, as 23 hours, 56 minutes, and 4.1 seconds. The modern accepted value is 23 hours, 56 minutes, and 4.091 seconds. His error is less than a single second, less than 1 second, in 499 CE, with no instruments beyond what he could build or observe with his own senses. I do not know about you, but when I discovered this, I felt something shift inside me. Now I felt the distance between ancient and modern collapse. I felt the arrogance of the assumption that intelligence is a product of technology rather than the other way around. Technology is a product of intelligence, and intelligence has always been there, burning in human minds since the beginning, regardless of the century, regardless of the empire, regardless of what tools the surrounding world had managed to build. Aryabhata also provided remarkably accurate calculations for the diameters of the planets. He described the orbits of Mercury and Venus as being closer to the Sun than the Earth, an insight that hints toward a partial heliocentric understanding of the solar system. He explained correctly that the moon and planets shine by reflected sunlight, not by their own light. He gave a scientific explanation for solar and lunar eclipses that was correct in its essential mechanism. The Earth's shadow falling on the moon's shadow falling on the Earth, at a time when many cultures still attributed eclipses to supernatural demons devouring the celestial bodies. But who was this man, really? What was he like as a human being? What did he dream about? What frightened him? What filled him with joy? History is frustratingly silent on the personal details of Aryabhata's life. We have the Aryabhatiya, and we have fragments and references from later scholars and commentators, and we have his approximate dates, born 476 CE, and believed to have lived until approximately 550 CE, making his lifespan roughly 74 years, which was a remarkable age for the time. But the intimate texture of his daily existence is largely lost to us. We know he was associated with Sumapura and likely the great university city of Nalanda, one of the most extraordinary educational institutions in the ancient world. Nalanda at its height housed thousands of monks and scholars from across Asia. It had libraries of immense depth. It was a place where you could spend a lifetime learning and never exhaust its resources. If Aryabhata studied there, or taught there, or was simply inspired by the intellectual atmosphere of that golden age of Indian learning, then he was surrounded by some of the greatest minds his world had to offer. Later traditions suggest he led an astronomical observatory. He had students. He had intellectual disciples who continued and expanded his work. His methods were studied and commented upon by great mathematicians who came after him. Names like Brahmagupta, Bhaskara, and eventually the Kerala school of astronomy and mathematics, which in the 14th to 16th centuries developed early forms of what we now call calculus, building directly on foundations that Aryabhata had laid. And yet Aryabhata wrote in the Aryabhatiya something that pierces me every time I read it. In the opening verses of his great work, after laying out his credentials and his intent, he wrote, and again I paraphrase from the Sanskrit, that by the grace of God, the precious sunken jewel of true knowledge has been rescued by me from the great ocean of true and false knowledge. He was not arrogant. He was grateful. When he was humble before the mystery of what he had been given, he understood that his genius was not entirely his own, that he was a vessel, a conduit, a finder of things that had always been true, always been there, waiting in the structure of the universe for someone patient and bold enough to discover them. That strikes me as one of the most beautiful things a mathematician has ever said. Now let me trace for you the extraordinary journey of Aryabhata's ideas across the centuries and across the globe, because this is where the story becomes almost mythological in its scope. After his death, the Aryabhatiya continued to be studied and taught in India. Commentaries were written on it by generations of scholars. The mathematical and astronomical knowledge it contained was preserved, refined, and expanded. The Indian traders and scholars carried this knowledge along the Silk Road and across the Indian Ocean. In the 8th and 9th centuries, when the Abbasid Caliphate in Baghdad sponsored the Great Translation Movement, an extraordinary cultural project in which scholars were paid to translate Greek, Indian, Persian, and other texts into Arabic, the works of Aryabhata were among the treasures that flowed into the great intellectual engine of the Islamic Golden Age. When Arab mathematicians and astronomers studied his scene tables, they used his astronomical calculations. They built upon his algebraic methods. The great Al-Khwarizmi, often called the father of algebra, whose very name gives us our word algorithm, was deeply influenced by the Indian mathematical tradition that Aryabhata had helped define. When Al-Khwarizmi wrote his famous treatise on arithmetic, he introduced the Hindu-Arabic numeral system to the Islamic world, the system that would eventually reach Europe and replace Roman numerals forever. And through the Islamic world, Aryabhata's mathematics, his sine function, his place value arithmetic, his algebraic methods, reached Europe. They crossed the Pyrenees with the Islamic scholars of Andalusia. They were translated from Arabic to Latin in the great translation movement of medieval Europe. They entered the bloodstream of European mathematics and science, where they circulated invisibly, unnamed, unacknowledged, like a river flowing underground. The European Renaissance, the scientific revolution, Copernicus, Kepler, Galileo, Newton. They stood on the shoulders of giants, but some of those giants were Indian. Some of those giants wore no armor, fought no wars, and built no monuments except the immaterial and eternal monuments of ideas. One Aryabhata was one of the tallest of those giants, and now I want to pause here and speak to you from the heart, because there is something deeply painful about this story that I think needs to be said out loud. Aryabhata's name is not a household name in the West. His face is not on any currency used by a global superpower. His birthday is not celebrated with the same fanfare as Newton's or Einstein's. Most people who use trigonometry every single day of their lives, engineers, architects, physicists, programmers, have never heard the word Aryabhatiya, have never heard the story of the 23-year-old who calculated the value of pi to 4 decimal places and understood the rotation of the Earth. Why is that? Part of the answer is the brutal machinery of colonialism, the centuries during which European empires systematically diminished and dismissed the intellectual achievements of the peoples they colonized, rewriting the history of human thought to center Europe and minimize everyone else. India was conquered, its traditions were denigrated, its scholars were erased from the global narrative. The story of mathematics was told as a story that began in Greece, took a detour through Rome, flickered back to life in the Islamic world, and then blazed fully to life in Renaissance Europe. India was an afterthought, a footnote, a contributor of raw materials to be processed by European genius. Way this was, and I want to say this clearly and without anger but with absolute conviction, a lie. A convenient, self-serving, historically catastrophic lie. And every time we tell the true story of Aryabhata, every time we speak his name with the reverence it deserves, every time we teach a child that the mathematics they are learning has roots in ancient India, we undo a little more of that lie. We restore a little more of what was taken. We honor not just one man, but all the countless brilliant minds throughout history who did the work but were denied the credit. This matters. This will always matter. Aryabhata died around 550 CE. He was, by the standards of his era, old. He had lived long enough to see his work studied, discussed, challenged, and absorbed into the living tradition of Indian mathematics. He had lived long enough to know that what he had built would outlast him. He was right. He could not have imagined how right. In 1975, when India launched its first satellite into space, they named it Aryabhata. The man who had measured the heavens with his mind was finally sent up into them on wings of steel and fire. The man who had watched the stars from the ground was now, in a sense, among them. His image appears on Indian currency. Streets and institutions in India bear his name. The Aryabhata Research Institute of Observational Sciences in Uttarakhand, India, one of the country's leading astronomical research centers, is named in his honor. Crater Aryabhata on the moon bears his name. The legacy of a man who never owned a telescope is now woven into the exploration of the very cosmos he dedicated his life to understanding. But his greatest legacy is not the satellite, or the crater, or the institutions bearing his name. His greatest legacy is invisible. It is everywhere. It is in every sin function ever calculated. It is in every algorithm ever written. It is in the decimal numerals we use to do everything from splitting a restaurant bill to navigating a spacecraft to Mars. It is in the very language of science, the equations, the tables, the conceptual frameworks that underpin the modern world. When you use GPS to navigate, you are using trigonometry. When you listen to music through digital speakers, you are using Fourier analysis built on sine and cosine functions. When your phone does a calculation, It does so in a number system rooted in the Indian mathematical tradition. When a doctor calculates a drug dosage, when an engineer designs a bridge, when a programmer writes code, they are all, without knowing it, walking on foundations that Aryabhata helped lay. He is everywhere. He just does not have his name on the door. I want to close this section of our journey together with something personal, and I want you to really hear me because this is the most important thing I'm going to say. Aryabhata was born in a world that had not yet invented the concept of a great scientist. There was no Nobel Prize. There was no tenure-track position at a prestigious university. There were no TED Talks, no bestseller lists, no viral moments. There was only the sky and the numbers, and the question, always the question, what does this mean? How does this work? What is the truth hiding behind what my eyes can see? He pursued that question with everything he had. He dedicated his life, or his entire life, to understanding. And he did so in verse, which is to say, he did so with beauty. He understood that truth and beauty are not enemies. He understood that the most rigorous mathematical statement can also be the most elegant, that numbers are not cold, they are warm with the breath of the universe itself. And somewhere across 15 centuries, across the wreckage of empires and the rising and falling of civilizations, across translation and mistranslation and appropriation and forgetting, somewhere across all of that, he reaches us. His voice is faint, but it is there, and it is saying, look up, think harder, go further. The universe is patient. It has been waiting for you to understand it since before you were born. That is what a great mind does. It does not stay in its own time. It travels. And now I have to tell you the thing I promised you at the beginning of this video. Oh, the thing I said would shake you. Are you ready? Here it is. When Aryabhata calculated the circumference of the Earth, he arrived at a figure of approximately 39,968 kilometers. The modern accepted value is 40,075 kilometers. His error was roughly 107 kilometers, less than 0.25%. But that is not the striking part. The striking part is this. Aryabhata was the first person in recorded history to calculate the circumference of the Earth using mathematical principles and astronomical observations, and to get it this devastatingly close to correct. An error of less than 0.27% in the year 499 CE, with no instruments beyond his own mind and the sky above him. Most people in the Western world credit Eratosthenes, the ancient Greek scholar who famously used the angle of sunlight in 2 different cities to calculate the Earth's circumference, arriving at an estimate celebrated for 2 millennia. Eratosthenes died around 194 BCE. He worked roughly 7 centuries before Aryabhata. And yes, his estimate was impressive. But here is what almost nobody tells you. The figure usually cited for Eratosthenes, the remarkably accurate figure, depends critically on which conversion factor you use to translate his measurement from ancient Greek stadia into modern kilometers. And historians disagree on this conversion. Depending on which stadia to kilometer conversion you apply, Eratosthenes' estimate ranges from seemingly accurate to significantly off, as much as 16% higher or lower than the true value. Aryabhata's figure was 0.27% off, unambiguously, provably in units we can trace directly, and yet it is Eratosthenes who is celebrated in textbooks around the world as the man who first measured the Earth. It is Eratosthenes whose calculation is taught to every school child in geography lessons. It is Eratosthenes whose story runs on science documentaries. Aryabhata's calculation sits in the Aryabhatiya. Largely unread, largely uncelebrated, largely unknown outside of specialists in the history of Indian mathematics. This is not an attack on Eratosthenes. He was brilliant. He deserves every ounce of credit he receives. This is simply a call, urgent, overdue, heartfelt, to also give Aryabhata what he is owed, to let his name be spoken in the same breath, to let the world know that in the year 499 CE, a young man in ancient India looked up at the sky, looked down at the numbers, and measured the very earth beneath his feet with a precision that staggers the imagination. He deserves to be known. He deserves to be celebrated. He deserves to be a household name. And maybe, if you share this video today, we can make that happen. One story, one share, one conversation at a time. That is the story of Aryabhata, the man who was born in the year 476 CE and who, in 74 years of life, might change the mathematical and astronomical foundations of human civilization so profoundly that the ripples have not yet stopped spreading. He calculated the value of pi to 4 decimal places. He proposed that the Earth rotates on its own axis, 1,000 years before the West accepted this truth. He calculated the length of the solar year to within 3 minutes. He calculated the Earth's rotation period to within 1 second. Now he developed the sine function that underpins all of modern trigonometry. He contributed to algebra in the study of indeterminate equations. He calculated the circumference of the Earth to within 0.27% of the correct value. And he did all of this in verse, in Sanskrit verse, in a universe that had no Nobel Prize and no academic institution to validate what he had discovered. He needed no validation. The stars were his validation. The numbers were his validation. Truth was his validation. If this video moved you, and I hope it did, please do these things right now. Hit the like button. Leave a comment below telling me what part of Aryabhata's story hit you the hardest. I read every single comment, and I would love to hear from you. Subscribe to Numbers and Narratives by Bless Right if you have not already, and share this video with someone who needs to hear this story. Because they are out there. The person who does not know the name Aryabhata yet. Not the student who thinks mathematics is cold and lifeless. The person who believes that genius comes from only certain places. Share this with them. Give them the gift of this story. History is not just about what happened. History is about who gets to be remembered. And today, together, we have just done something small but real. We have said the name Aryabhata, told his story, and made him a little less forgotten. Thank you for being here. Thank you for watching all the way to the end. And until next time, keep counting, keep questioning, and never stop looking up. This has been Numbers and Narratives by Bless Right. The numbers remember, even when the world forgets.